Okay, I've got some examples of some functions here we want to take the derivative of and the second derivative. So I'll start out with something very simple, 2x cubed plus 1. Find the derivative of that. Will give me 6x squared. And finally, the second derivative is just the derivative of the first derivative. So in this case, it turns out to be very simply just 12x. The mechanics and the rules for finding a second derivative are really all the same in finding a first derivative. It's just that in the second derivative, you're taking the derivative of the first derivative. Think of something here a little bit more complicated maybe. 4 minus x, the square root of 4 minus x. Taking the derivative of that, I'm going to treat that square root as the 1/2 power. So 1/2 4 minus x to the minus 1/2. And then times the derivative of the inner function there is a minus 1. So that leaves me with minus 1/2 4 minus x to the minus 1/2. Now to take the second derivative, I would have a positive 1/4 4 minus x to, and we'll subtract 1 from the minus 1/2 to get a minus 3/2. And again, don't forget to take the derivative of that inner function. That'll leave me with a negative 1 over 4. I'm going to take that 4 minus x, the minus 3/2, down to the denominator and write as the square root of 4 minus x quantity cubed. So my second derivative. Now we'll try another one. How about h of t is equal to t squared over t minus 1. And in this case, I'm going to have to use the quotient rule to take the derivative. I'm going to take the derivative of the numerator times the denominator. Separate this a little bit here. And then the numerator times the derivative of the denominator all over the denominator squared. So cleaning it up a little bit, I have 2t squared minus 2t minus t squared all over t minus 1 squared, which finally turns out to be t squared minus 2t over t minus 1 squared. So that's my first derivative. Now to get the second derivative, I'm going to have to use the quotient rule again on the first derivative and take the derivative of the numerator. Make sure you get those in parentheses. Times the denominator. Subtract the numerator. Times the derivative of the denominator, which is 2 t minus 1 to the first power, and then times the derivative of the inner function there is 1. And that's over t minus 1 to the fourth power. So I'm going to square the denominator. I had t minus 1 squared, now it'll be t minus 1 to the fourth. Okay, now the next thing I'm going to do is clean this up just a little bit. I'm going to pull out a 2 there, and I'm going to pull out a t here, and simplify this just one step here. So I'm going to have 2 t minus 1 times t minus 1 squared minus 2t times t minus 2 times t minus 1 all over t minus 1 to the fourth. Now looking at this, I can pull out a t minus 1 common factor. I really have two terms here. I have this term subtract this term. So I'm going to pull out a t minus 1 and a 2. I also have a common factor of 2 with these terms. So I'm going to write this as 2 times t minus 1 times the quantity t minus 1 squared minus t times t minus 2. And then in the denominator I have t minus 1 to the 4th. Of course I get a little cancellation there. And now I have 2. I'm going to go ahead and square this t minus 1 and get t squared minus 2t plus 1. And then I'm going to go ahead and distribute in that minus t into that quantity. So I have a minus t squared plus 2t and over t minus 1 cubed. So I have 2 times, let's see, the t squared cancel each other, the minus 2t and the 2t. So I just have 2 times 1 over t minus 1 cubed, or 2 over t minus 1 cubed. And that's my answer.